Okie dokie, Lexi, here is lesson 66, number 24. This is the last problem of the lesson and the last proof that we need to do. You're going to notice up in the upper right-hand corner, I have a little picture here of the diagram that we're actually trying to prove some things on. Let's look at what we're trying to prove here. So we notice that according to the proof statement here, we want to prove that triangle DPB is isosceles. So let's find that so we know where we're headed. DPB, that is this triangle right here. I'm going to color it in yellow. We're trying to prove that that's an isosceles triangle. Well, then we know if we're trying to prove that as an isosceles triangle, well, then that means I have to prove those two sides are congruent, right? Because remember, on an isosceles triangle, it has two congruent sides. So we're trying to prove that somehow throughout what's given to us and what step we can gain from the step before. All right, so we have this rhombus, and the good news about a rhombus, we have some rules and theorems and definitions and such about a rhombus. So we're going to use those to get through this proof. So let's go ahead and write down what is given, which is very simple, rhombus ABCD. Okay, that's the only thing they tell us is that this is a rhombus. And from that, there's a lot of things we can get. We know that the diagonals in a rhombus, these two right here, I'm going to draw them in pink. This line that's intersecting this line does a couple of different things. In a rhombus, where it intersects, it creates four right angles right there. They're perpendicular lines. Okay, so that's one thing we know. The other thing we know is that in a rhombus, a diagonal, when it comes into a vertex, like down here, it's coming right from D over to B, it bisects those angles. So all four of those angles on this rhombus, those diagonals, are bisecting in there, which means what? That means that those angles where it's bisecting, it's cutting that angle right smack dab in the middle. Okay, so it's creating two congruent angles. Okay, so let's start from there. Well, that gives us some information to think about. So the first thing we want to look at is step number 2. DB and blank are perpendicular. Well, I just talked about that. So that means this diagonal is perpendicular to this diagonal, AC. And the reason there is just the definition of diagonals in a rhombus. The diagonals of a rhombus are perpendicular. Remember, the sign for perpendicular looks like this because it means it's making right angles look like that. Okay? All right. Step 3. Well, if those turn out to be perpendicular, then that means it's making right angles, as I just mentioned. So let's see if we can match these up. So COB right here, let's go find that. COB. I'm going to get rid of a couple of things here. Get some of this off of here. Okay. So COB is right here. COB, this right angle. And I'm going to focus on the one right next to it, which is DOC, right here. Because remember, we're trying to prove this triangle is isosceles. So I'm going to focus on what I can inside those triangles, inside that triangle. All right, so what did I mark? I marked CDO? No. Sorry, DOC. So DOC and COB are right angles. And why is that? Well, like we stated earlier in step number 2, perpendicular lines intersect to form right angles. Okay, so not only are they right angles, since they are right angles, both of them, that means they're congruent to each other. So for a reason, we're just going to write all right angles are congruent. They're all 90 degrees, right? All right angles are congruent. All right, number 5. Here's where we're going to look at okay, I mentioned that they bisect those angles, which they do, but I want to bring up another point that I didn't bring up in the beginning. So you can see on step number 5, we're going to be looking for line segment OB. So let's go find that, and I'm going to mark it in a different color. I'm going to choose, what don't I have here? Green. Okay, so OB is going to be congruent to some other line segment. So let's look at this. Here's OB. Okay. Well, we know then that DO has to be congruent to it. Because look at the reason. If a quadrilateral is a rhombus or parallelogram, but in the specific case, a rhombus, then the diagonals bisect each other. Remember, that means right at that center point that I'm going to color in pink up here in the diagram, right there, that intersecting point of those diagonals, it has created equal line segments because it comes right through the middle, okay, creating 2 line segments that are congruent. Okay, so far, it looks like we're getting somewhere. I have a line segment in, let me see here. Hold on one second. Okay, yeah, those 2 line segments are congruent. Now remember, we haven't yet actually proven these. I'm going to take those little pink tick marks off because we have not actually proven those congruent just yet. Remember, I marked those to say, here's what we need to find out, though. In order to call that isosceles, those two line segments do have to become congruent. So let's see if we're almost there. Number 6. Oh, we see the reflexive property. So if you look at these 2 little triangles right now, what I'm going to do, I'm going to actually color one of these triangles in blue. Because what we're doing here is we're going to prove 2 triangles congruent first. Because if I can do that, then you're going to have corresponding parts congruent. And you'll see where I'm heading in just a moment here. If that's not making much sense to you, it will in just a moment. Okay, so let's go down here. So reflexive property. What line do each of those triangles share? Looks like this one right here in the middle, right? PO is actually congruent to PO or OP or however you want to state it. OP is congruent to OP because of the reflexive property. Both that yellow triangle and that blue triangle share that side. So it is congruent. So now we have the green tick marks, excuse me, which is a side. We also have the angles, the right angles, which is an angle. And then we have the side that's reflexive, which is OP, which is also a side. Can't squeeze that all in there, but we have side, angle, side, side, angle, side. Okay, so there we have that. So now I can make the statement that triangle DOP is congruent to BOP because of side, angle, side. Okay, so we got those 3 parts. We showed those congruent. That's good. Now, number 8 states in the proof that DP and PB are congruent. So let's go find that. DP, and I'm going to put 4 line little tick marks there. DP and PB right here. 1, 2, 3, 4. Oh, we did it. We were able to prove those 2 line segments congruent. And why are they? Because of the CPCTC, right? All we need are 3 parts of a triangle that corresponds with 3 parts in another triangle to say that those are congruent. And once those triangles are proven congruent, then every part in there is congruent with each other. Okay, so now we can say that those 2 lines that we have been dying to get to, DP and PB, are congruent. Those were the 2 that we needed to state congruency to in order to state that that is an isosceles triangle. Okay, so based on the fact of all of that and proving, look up here in the diagram, proving this side equal to this side, doing that shows us that the definition of a isosceles triangle is what we can use to make the statement that that is in fact an isosceles triangle. Alrighty, I hope that made sense. Thank you for watching.